When light travels from one medium into another, it refracts, depending on the speed of light in one medium compared to the other and their respective refractive indexes. Now, it doesn't necessarily have to be a separate medium. For example, the refractive index of air is density dependent. Hot air has a lower refractive index than cold air. This is why we see things like mirages coming off of asphalt on a hot summer's day. So if we have our street and a layer of hot air just above the street, light coming down onto this hot pocket bends. And if light is coming from beyond the critical angle, it's going to reflect. And that's how we get mirages. Now we can demonstrate this by having this hot plate stand in for a hot street, and we'll see the light refract from it. And what could be more appropriate than the Feynman lecture's own chapter on refraction? Look at those words wiggle. We can take advantage of this behavior to actually see these areas of hot air. Our setup starts with a lamp, an LED in this case, and a parabolic mirror. They're separated by about 2 times the focal distance of the mirror, because then our image and our lamp are the same distance apart, and that makes it a little bit easier to work with. Now, just a little bit past where that image forms, we put our camera. So what the camera is going to see is a big white circle where this mirror is. Now, what happens if we put something really hot right in front of the mirror to create this volume of hot air? The light ray that goes through this hot area is going to refract. And it's going to go just a little off from where the image formed. Now the hot stuff is always going to refract the light downward. So we can block all that light that's coming from the wrong angle just by putting something in the way. A blocker. So now this light beam that was originally going through that hot area doesn't get to the camera at all. It's going to show up as a little dark spot on the mirror. So here we have our LED lamp, our camera, and for our blocker, we're using this little razor blade. Now right now I have the camera pointed at the mirror, and we'll switch to that. We can see what happens once we turn on our LED. I'll just focus it. So now I'm going to take this here candle and light it. You can see in the direct image from the camera, nothing's happening near the candle. But in the Schlieren setup, you can actually see the heat coming off of the candle. Just for fun, let's see what happens when I point a blowtorch past it. about this hot plate? How about this resistive heating element? Now, to add a little turbulence to the system, I'm going to try blowing on it. With Schlieren optics, the fun never ends.